Welcome back to the series name In the Search of Shooting a Cat, and now in the story. Now we have another story on the topic name Wave Particle Duality. In this topic, we talk about the duality functions of light. How a light demonstrates itself like a wave or like a particle at the same time depends upon how we observe it. And by this, the scientist also confused what is the light's real form, a wave or a particle. And in this topic, we also focus on that what's the true nature of light. So stay with this. I hope you enjoy. So, light, the very essence of our vision, the silence, witness to the birth and death of stars. But what it is, a wave or a particle, or something beyond human intuitions. To answer this, we must journey through the minds of history's greatest thinker, Newton, Huygens, Planck, Einstein, and ultimately Schrödinger. So, Newton believed light was composed of tiny invisible particles, corpuscles. He called them small shift and obedient to the rules of motion. But the idea that light could be made of particles did not still well with anyone. Okay? Huggins argued light moves like a repulse on a pond. It bends around object, diffracts through narrow slides, and interferes constructively and disconstructively. If it were particle, how it could be behave like a wave? Or thus began a war of thoughts. A duel between particle and waves then would span centuries. Okay, Young's experiments was the death knell of Newton's corpuscles. A beam of light split into two created a pattern of alternative light and dark bands. If light were particle, such behavior would be impossible. Waves, it seems, had won. But truth is never so simple. Then came a revolution no one saw coming. Max Planck, trying to solve the mystery of black body radiation, proposed that energy was not continuous, became in tiny, but came in a tiny invisible packets named quanta. We will talk about this quanta in the series of these videos and stories, so you know about that. If you don't know, just please watch. I suggest you to watch the past videos, past two or three videos of my series, okay? So let's continue. The foundation of quantum mechanics had been laid, and at its heart, light was no longer just a wave, it had a particle like behavior according to Max Planck. Like because he said like it's a quanta, it's a packet of energy. So a packet means a source of tiny particles. Like a particle holds some kind of energy, an object holds some kind of energy named quanta. So it's behave like in a particle now. So what's that? It's confusing now because some says wave, some says particles. So where's the story begins? Let's do. Einstein took Planck's idea and denoted a bomb in classical physics. And what's that? The photoelectric effect. Light hitting metal and releasing electrons. When a beam of light hit any object, it's energized the electrons in the orbit of that atom and bounce back in an angle and hit the electron and electron bounce back in an angle. So that's done in the photoelectric effect. Could be explained its light behaved as a particle. Photon he called quantum packets of energy. The photons. At that time there are the quantum packets like quanta about the Max Planck. The wave particle paradox had returned fiercer than ever. Okay, so light is both a wave or a particle, but how? How can something be two things at once? That's the real question that's terrifying the whole physics, whole quantum mechanics. Okay, perhaps Dr. Cates is not light that is paradoxical, but our way of seeing the world. The uncertainty principle shattered the illusion of the determinants. We could never know both of particle positions and momentum with perfect preference. Okay, light, electrons, the fabric of reality itself, they existed in a cloud of possibilities until measured. It was as if the universe itself reduced to reveal its hand. Okay, Schrodinger's despised this idea, a world dictated by chance, abused to expose the madness. He devised a thought experiment, a cat trapped in a box with a radioactive atom. If the atom decayed, the cat would die. If it did not, the cat would alive. But quantum mechanics instead, the cat was both dead and alive at the same time, according to quantum mechanics. But until we observed. Okay, so if it's watching me, it's know when I observe. What is light? A wave, particle, neither, both. Perhaps the deeper question is, what is reality? And do we shape it simply by looking? Ah, that's still a question for us. The delayed choice experiment would push quantum reality to its limit. Could a particle decide how to behave based on the future events? Was time itself the part of illusion? That's also another question in the series, okay? So, choice. Light chooses. But who is the chooser? The universe or us? If is we choose to light to behave like particle or a wave, or the laws of universe choose to behave that light is behave like particles or a wave. It's still confusing and getting confusing and confusing if we go deeper and deeper and deeper. So Einstein called it spooky action at a distance. Two particles, light year apart, instantaneous connected. If one changed, the another did too. Faster than light, reality it seems was woven until unseen threads. Do we create reality just by looking? The deeper we look, the stranger it gets. But one thing remains clear: to understand lights is to understand the nature of existence itself. And we only are at the beginning. So, this is the story about lights, particle wave duality. So, for uncovering the reality of lights and wave, we need to uncover some other experiments that happened in the past and now continuing in the future to know the reality of light as it is. So stay with me in the series and I will surprise you in the next video by I don't reveal the name. So we will meet in the next video.